So it will be in vertical direction. And the main important parts of this Kaplan turbine are guide vanes and the runner vanes and the shaft and the scroll casing and the draft tube. These are the main important part of the Kaplan turbine. And we'll try to understand what are the specific functions of these. We'll try to see them. The scroll casing is one which will be having the varying cross section. This is one other way we can say it is a pipe, just like a pen stove. From the reservoir, we are going to take the water through this scroll case. The scroll case, what happens here, it will be having the varying cross section. The varying cross section will be there, and this will be entering this. We'll see that later. And the guide vane. The guide vane will be directing the water, which will control the flow of water onto the running vanes or the runner vanes. Okay, and there we had the nozzle. Here we have the guide vanes. And the runner vanes, those will be coupled to the shaft of this Kaplan turbine. These runner vanes, once the water is striking over this, what happens? These will start to rotate. Since this will be coupled to this shaft, the shaft also will start to rotate. And this draft tube is one which will be having the varying cross section. At the outlet, it will be having maximum cross section, and here it will be having the lesser cross section. So that slowly, gradually, the velocity will be reduced and it will enter into the river or outlet. Okay, these are the main important parts. Now we'll try to understand the working principle of Kaplan turbine. How the Kaplan turbine will be working. The water from the penstoke, enters this scroll casing. The scroll casing will be having varying cross-sectional area. So due to this, there will be variation in the pressure and the velocity. And here at the guide vane, what happens? It will direct as well as it will control the flow of water into the runner vanes. Okay, and the directed water which is flowing through this guide vane will be falling onto these runner vanes. These runner vanes will be having the spiral structure, and what happens while the water enters into this without having much more friction, which will be gliding onto the runner vanes. So due to this, a thrust will be developed. So due to this thrust, what happens? It will start to rotate in the opposite direction. Okay, and due to this, the shaft also will rotate. So finally, what we required? We required to rotate the output, or we required to rotate the shaft. The output shaft have to be rotated. We have to get the mechanical output from the shaft. This will be coupled to the alternator, which will develop the AC current. This is what we need to understand. Okay, please try to remember this much. The water from the penstoke enters the scroll casing. The scroll casing is a pipe which will be having varying cross sections, and from here the water will enter the guide vanes. The guide vane, as the name indicates, it will guide the water to get into or let into the inlet vanes. Okay, and at the same time it will control the flow of water onto the vanes. Okay, once the water leaves this guide vanes, it will enter the runner vanes or running vanes. What happens? Due to this, it will start to rotate. Once the resultant force is generated, here what happens? Which will start to rotate at very high speed. Continuously the water will be flowing onto this, continuously it will be rotating, so that there will be increase in the velocity, the running. Okay, and the shaft will be giving you the mechanical output. This will be coupled to the alternator, and alternator will be giving you the AC current. This is how the Kaplan turbine will be working. And try to remember, the draft tube is the one which will be at the tail race. Tail race means once water is performing it will exert the force onto the vanes, which leaves at atmospheric pressure, and the velocity also will come down while it is flowing to the tail race. The tail race is one. It is simply after performing the work, water will be leaving the turbine. That will be called as a tail race. Okay, and the tail race will be having a draft tube. The draft tube is the one which will be having varying cross section. Varying cross section will be there. At the outlet, it will be having maximum cross section, and near to the vane, it will be having the smaller cross sectional area. And these designs will be very specifically made for the Kaplan turbine. Okay, and let me get into the other turbine that is called as a Francis turbine. Francis turbine is having different design. The working principle will be same, but the functional the accessories which are available, assemblies which are available in the Francis turbine will be slightly different. Let me try to understand what are these, what are the individual function of these. We'll try to see them. And this is called volute. This is volute or a casing. You can see one can make a small observation. At the inlet, the cross section will be more, and now it will be entered here. It will be having a lesser cross sectional area. Okay, it is eccentric cross section. You can say eccentric. The shaft will be mounted eccentric with the casing, so that there will be a larger cross sectional area, and then now we come this side, it will be having a minimum cross sectional area. It is called as volute. And actually here the water will be entering this space. And now here in the Kaplan turbine as well as the Francis turbine, we had the vanes or the blades or buckets. Those are fixed over the runner. Now here we have the fixed blades and the moving blades. The fixed blades are called the guide blades or guide vanes, and the runner vanes are called running vanes or vanes, which will be directly fixed over the runner. Okay, and now these fixed vanes, the guide vanes or fixed vanes, what they do, we had the individual nozzle in the previous case, as in case of the Pelton turbine, but here all these will be acting like nozzle. You can see that the curved vanes which are fixed is in the casing, those will be acting like nozzle while the water is entering here, which will be acting like nozzle because the cross sectional area will be maximum, and as now it will come here, the cross sectional area will be lesser. Okay, and by gliding water, what happens? The friction, without friction, the glided water or water which is flowing through this will enter the runners or running blades. So here the reaction will happen so that the runner will start to rotate at very high speed. Please remember, the water will be leaving the Francis turbine axially, which enters like this, and axially which will be leaving the turbine. Okay, so main important parts of this Francis turbine are, these are also called as axial turbine because the water is leaving or outlet of the water will be axial. Okay, and it consists of a volute or a casing which will be having the varying cross section, and we have the two types of blades or vanes. One is a guide vane which will be directing the water, and another is a fixed vane. This is a guide vane or a fixed vane, and another one is runner blade or runner vanes or runner buckets. Those are fixed on the rotor of the turbine. Okay, these are the important parts. Then how it works, we'll try to see them. At a particular head, water is made to enter into this casing through the penstock, and what happens while the water is flowing here, it will enters the guide vanes or fixed vanes. Once it enters the guide vanes or fixed vanes, it will be directed to flow into the runner vanes. When the water entered the runner vanes at very high velocity at atmospheric pressure, what happens? The rotor will start to rotate. Since the rotor is rotating, already you know that it will be coupled to the shaft. The shaft also will rotate. We get the mechanical output. If it is rotating, it is understood. We have the mechanical output. This mechanical output will be converted into electric energy once you couple this with the generator. When you are going to couple with the generator,